Okay, so 1.5 combination of functions. So this is what you learned prior, sum or differences. So these are just the formula. So f of plus x means you're adding them, differences where you're subtracting them, product, multiplying, quotient. So you're dividing. The only thing you gotta be careful of is the denominator cannot equal to 0. And then composite function. The second term is what's going inside the function, the first function. So that's why f of g means you're plugging g of x into f of x in this case. So you're just substituting. So for number one, it says find the four combinations for f of x of 2x minus 5 and g of x of 1 minus x. So, do number one. So the first composite function is just adding them f of g of x. So that means you can combine f of x, which is 2x minus 5, plus g of x, which is 1 minus x. For combining like terms, 2 of x minus x, it's just x. Negative 5 plus 1, negative 4. So that is x minus 4 for f plus g of x. For number two, we'll do f of minus g of x. So you're subtracting them. 2x minus 5. This is the only one you have to be careful when you're plugging in because you're going to have to distribute the negative for 1 minus x.
So anything like on the G can be negative based on what you saw this.
Yeah, you just flip the sign. So that one it was positive, now it's negative, the negative x becomes positive x. So same thing, combine like terms, 2x plus x is 3x, negative 5 and negative 1 makes negative 6. Pretty easy, pretty easy. For number three, f times g of x. So this is where you're gonna have to multiply. Oops. 2x minus 5 and 1 minus x. Oops. In this case, you could do the Cherevier property, but personally, I like the box method. Just it makes it a lot more neater. 2x minus 5, 1 minus x. 2x, negative 2x squared, negative 5, 5x. And then just rewrite it. And then combine like terms. Then you get your answer. And then for the last one is the quotient. So f divided by g of x. So f of x is 2x minus 5. And then we have 1 minus x. You cannot simplify this any further. So that's just the answer. But you have to include the restriction. So in this case, x cannot equal positive 1. So that is your domain restriction for this equation. Does anyone have any questions? All right. For the next example says find f of f times g of 3, 2 squared for the above function. So for this one, there's more than one way to solve this problem. You can either substitute then multiply or multiply then substitute. And it's your preference. Personally, for me, I like to just do the procedure first and then plug it in. So we'll just do that because we actually already did f of g, f of x, f of g of x. Yeah. Okay. So f of x is negative. Wait for the above function. Yeah. So this is
You multiply the three and the exponents of both the f and g, or just one?
just one.
Okay.
Okay, so in this case, we did f times g of x already. So we got negative 2x squared plus 7x. So this is from the previous problem, which is this one right here. So we already did it. Just know if they're together, it's the same thing as multiplication. So that's why I put the multiply sign. So just remember that. And technically, f of g is the same thing as f times g. So just because they didn't put the multiplication sign, it means the same thing. Does anyone have any questions? The only one when it's different if it has a circle in between. That's a composite function. So you have to know the difference between both of them. Okay, so since we already did f times g, I'm just gonna rewrite it. And then all I have to do is just plug it in. So as you can see here, I wrote f of g, f times g of x. And then for the next one, f times g of 3t squared. This just means that I plugged in 3t squared for x. The notation matters, so be very careful. That's 5. And then you just multiply. So remember, you always got to do exponents first. So negative 2. 3t squared to the power of 2 is 9t4, right? 3t squared times 3t squared. 3 times 3 is 9. T squared times t squared, t to the fourth. 7 times 3, 21. Distribute the negative 2. So a lot of substituting. Does anyone have any questions? Pretty easy, not too bad. Okay. So this one says find f of g and g of f, and then f of g of 0. Okay, so let's do fog first. So, so for a, f of g of x means we're gonna take 3 and we're gonna plug in g. So that means it's gonna be 3 times f5 minus x plus 5, meaning I took my function g and plugged it in to my function f. That's what fog means, fog of f of x. You can also rewrite it as f of g of x. These mean the same thing. And then you just have to simplify. 15 minus 3x plus 5. 20 minus 3x. They didn't even have any questions. You always like to write it in standard form, so negative 3x plus 20. So for part B, so this one's going to be golf or g of f of x. So that means you're going to take your function g and you're going to plug in function f. Simplify. 5 minus 3x minus 5. Negative 3x would be your answer because the 5 and negative 5 end up canceling out. Any questions so far? Good. For part C, it says to find f of g of 0. So that means f of g of 0. So we already solved for it, so we're just gonna plug it in. So you'll end up just getting 20 as the answer.
Basically, it's like your x is equal is plugged in as either g or f of the other one.
Yeah. So you're literally just doing substitution. A lot of substitution.
This is one for me being thorough in this lesson to me thinking it's gonna be the easiest thing ever.
It's not too bad.
Let's just add, just wait until we start adding more steps and then you're not gonna be able to do that.
Okay. The last part, I determine the domain of f of g and f of g. So the last one. So f is x squared plus 1. So what's the domain for this function, for this quadratic function?
Negative and then need the positive.
Very good. Or in this case, you can say all real numbers too as well. But yeah, the domain is negative infinity to positive infinity. For part B, what's the domain of g of x? So in this case, what's the domain for a quadratic, for a square root? Close. What's the notations for it though? Yes.
Would it be bracket 0 to?
Yeah.
Uh,
Parentheses. That's important. Or you can also write it as x greater than or equal to 0 as a domain as well too. There's a lot of ways of writing it. The other way you can write it, which I learned this year too, is you can also write it in this form
oh, yeah.
and this way. I usually don't write this way. Usually it's more notated this too, and then this one is if you want to get super fancy.
This way we only ever did that, and this way we did piecewise functions. And
Yeah.
We would do, like, x equal, what it's called, of, like, or, yeah, whatever. It's easy, I think.
Yeah, usually you only see this during piecewise function, but this is also correct if you want to write it this way too. But yeah. For the last part, to find to find the to find the domain for a composite function, you're gonna have to take it to account. So this is fog, right? So f fog. So this is just f of g of x. You will get parentheses. So plug in g of x into f of x. So you should get square root of x squared plus 1, right? If you simplify this, what would you get? Just x plus 1, right? So what would be the domain? Unfortunately not. If you had just x plus 1, that would be correct. But this is the original equation. Anytime you're trying to find the domain of a composite function, you have to take into account the original equation. In which in this case, the domain for the original equation, you have to still take into account the square root, right? X has to be greater than or equal to 0. So that's what the actual domain would be. If you actually try to graph this on Desmos, you would see that it is actually correct. So here I have the square root of x squared plus 1. As you can see here, the only thing that's missing is everything the left side of the 0, right? So that means the domain of this function is x squared, is x greater than or equal to 0. So everything on the left-hand side is erased, and you're only left everything to the right-hand side. But you actually need the new function to graph it. So for example, if we were actually trying to graph this, you would need this new function to graph it. So I should give you guys a
But you need that function, but you plug in the other domain.
right. So for example, you guys can graph square root of x squared plus 1, even though it's kind of hard looking at this, but when you simplify, you get x plus 1, right? So you can actually graph that, right? At the y-intercept at 1, right? Rise over run, 1 over 1, right? And then you can use a ruler to graph it. But then you're gonna have to use the restriction of the original function, which is this one right here, which is x is greater than or equal to 0. So you can just erase everything on the left-hand side, and that's how you get the actual graph for it. Does that make sense? And that's why when you try to graph it on decimals, you're not graphing this, you're graphing this right here. But you can actually graph it by hand by simplifying it and then just use regular slope, rhizome run, and then the y-intercept. And then just erase everything on the left-hand side of 0 to get the actual graph. Does anyone have any questions? All right, other than that, that's the end of today's lesson.